recording. Okay. Hey, good morning to everyone who's joined us so far. I see Colin's back, Jackson's back, that's great. Megan's back. Some repeat folks, that's good to see. Okay. Okay, so I'll just go ahead and start, and then Zoom will kick folks in as they join. So thanks for joining us for our third webinar in this fall series. If you don't know me, my name is Brad. I'm the Executive Director here at the Alberta Lake Management Society. And helping to facilitate the session today is our Program Manager, Caleb, who also happens to be our second speaker for the day. If you weren't able to join us last week, we had two great sessions. They're now posted on our website. You can find them on the webinar page, or you can also find them on our YouTube page. And we have today's sessions and then two more next week. So I hope you'll join us next week. You can just use the same Zoom link to access next week's session. Today's session is being recorded. If you have any questions, please just submit those using the Q&A function at the bottom of your screen. It's harder for us to track if you put them in the chat. So just throw them into the Q&A session. And as usual, if you submit a Q&A or if you submit a question, we have a little draw that we'll do. So anyone who types in a question, we'll put your name in a draw. And this week we're giving away a Alms Lake Watch 25th anniversary t-shirt. We just had these made, a nice new 25th logo designed by Caleb Sinn. So submit a question, and yeah, we'll put your name into the draw and get that prize sent down to you. So with that, I think we'll just go ahead. Oh, what I will say too is if the program crashes at any point, just try and re-access the link. And if we can't get it up in like 10 to 15 minutes, then we'll have to just reschedule. So hopefully we don't run into any technical issues like that. Okay, so our first speaker today is Candace Parks, and Candace is or has been with the Manitoba Government Aquatic Invasive Species team. She's the Aquatic Invasive Species Specialist there for the past 12 years. She is responsible for aquatic invasive species communications, public engagement, and adaptation management programs. She's also played an integral role in the development of Manitoba's aquatic invasive species laws. She lives in Winnipeg with her husband and 3 young boys. No doubt, Candace has a busy job, so I'm really, really grateful that she's giving us some of her time this morning. So with that, I will just pass it over to you, Candace, and it looks like we're still seeing your screen. It all looks good, so you can take it away.
Awesome. Well, thanks very much, Brad, for the invite. And I guess thanks to my colleagues in Alberta for suggesting that I present today. So thank you, everybody, for making this presentation possible. So what I'm talking about today is essentially Alberta's best defense against aquatic invasive species. And so just learning from Manitoba's, I guess, as Brad put it, successes or past challenges, that's sort of what I'll talk about today. So just before we start, one, I hope my dog doesn't start barking. I'm sort of in my basement right now, so fingers crossed he stays quiet. 2, if you have a question, like a burning question, I think Brad's gonna help with that during the presentation, but you could also ask me during the presentation or afterwards. More than happy to answer those when you have them. So again, I am Candace Parks. I work in Winnipeg. I am the Aquatic Invasive Species Specialist. I am going to shorten Aquatic Invasive Species to AIS, just to save me from saying more words. So just everybody knows, in case I say the acronym, that's what I mean. So to start, I thought I would keep this very easy and straightforward, but here are the main questions or some of the agenda items I'm gonna go over in this presentation. So what are some of the impacts of zebra mussels that we're seeing in Manitoba? That's number one. Number two, what is the spread like in the province? What is and or will be our response and our containment look like for zebra mussels in Manitoba? And then hopefully for Alberta's benefit, some of the lessons learned from Manitoba's experience with zebra mussels in the province. So just to start here, just so everybody really knows what we're talking about here, I'll just talk about sort of AIS impacts, which also could be zebra mussel impacts. So many people may know about these, but I'll just take a few minutes to go over some of these. So when it comes to zebra mussels specifically, there has been some detrimental decreases in recreational areas and value. Example, beaches and shorelines. And so I'll just show you, I think this next slide here shows you, this is actually a beach on Lake Winnipeg. So this is Grand Beach. Grand Beach is probably one of the most famous beaches we have in Manitoba. It's one of the top 10 beaches in North America. And it's really powdery white sand beaches. It's several kilometers long. And as you can maybe see here, there's it's probably about maybe 5 feet wide of space of zebra mussels covering the shoreline area of Grand Beach. So now you'd have to walk over these shells, which could be sharp, to go into the water. And this is a picture I took from August when I was out at Grand Beach camping with my family. And this picture I know is a little grainy, but it just goes to show sort of the scale. Again, this is Grand Beach. This is from the May long weekend from this year. And there's a front end loader picking up those piles of zebra mussels that have now accumulated on Grand Beach. And now they're dumping them in the back of that truck and hauling them away onto a parking lot just to store them there. So this sort of shows you the scale of some of the impacts of zebra mussels on our beaches or shorelines around our invaded water bodies, specifically like Lake Winnipeg. So just going back to that slide here, so some other decreases when you have AIS is food availability and habitat quality for native species such as fish and native mussels. In the bottom right-hand corner of the slide here, you can see a native mussel. I put a quarter on top. That's a mussel from Lake Winnipeg again. And you can see that accumulation of all those zebra mussel shells on that poor native mussel. So what happens is that native mussel, where there is no zebra mussels, burrows in the sediment or the sand. And that top part, which is now covered in zebra mussels, is the part of the mussel that actually opens and closes its shell to respire. The zebra mussels will actually attach to the native mussel so much so that the weight will prevent that native mussel from opening its shell, so it cannot feed and it cannot breathe, so essentially suffocates and kills the native mussels. So that's one example of what could happen. I think I have the next slide here shows some other impacts here. This is a boat that this is some crew from the Manitoba government doing some gill netting. And this is sort of in Lake Winnipeg, but shows when all the zebra mussels that have accumulated when pulling up gill nets. I guess they're being pelted by zebra mussels when they're actually pulling up the gill nets over the side of the boat. So this is sort of some of the things that we are seeing in Manitoba. And then we're also seeing maybe some biodiversity losses in places such as Minnesota and Ontario. There has been waterfront property values have declined, sport fish opportunities have declined, and tourism recreational incomes could be declining as well. We are maybe seeing some of that now. It hasn't been really well documented, but I know many Americans would love to come to Manitoba to fish, to enjoy our 100,000 water bodies. They actually will avoid water bodies with zebra mussels in them, or they have said to me point blank, we come to Manitoba because you guys don't have zebra mussels in the past. So this can have negative impacts for tourism and recreational income. In addition, AIS can increase competition for native species, habitat loss, watercraft maintenance costs. So we'll talk about sort of the stages of zebra mussels in a moment, but for example, a zebra mussel veliger, which is the baby phase, actually they're free floating, could go into the water intakes of watercraft motors and start making their shell and clogging the motor. So motors of watercraft generally rely on cold water going through the motor to cool a system off. But with zebra mussels now clogging that water intake or that pipe, there'll now be no cold water to cool the motor, which could result in the motor overheating and burning out. Also, having zebra mussels attaching to the bottom of watercraft can increase drag and gas consumption. That's some of the things that we may start to see here in Manitoba. Also increase in water treatment and water delivery infrastructure costs. So this could also increase utility costs. So for example, Manitoba Hydro in Manitoba here, they're trying to keep the lights on for all of us here. Now they have to deal with zebra mussels potentially clogging their pipes. As you can see here in this bottom picture, you can see some adult zebra mussels clogging a pipe. So of course, when Manitoba Hydro takes, resources to clean the zebra mussels or prevent them from occurring in the hydro dams, those costs will be eventually put onto the consumer. So also we're seeing in Manitoba increased taxes potentially in areas where zebra mussels have established. So there has been, for example, there's a community in the south basin of Lake Winnipeg called Victoria Beach. They draw their drinking water supply from Lake Winnipeg. So of course now there's going to be zebra mussels clogging that pipe, which will also result probably in increased taxes onto that community. So there's some of the things that we could notice with aquatic invasive species and or zebra mussels. So just so everybody knows that, even though I'm focusing on zebra mussels today, Manitoba unfortunately has more than zebra mussels in the province. We have such as some things as black algae, spiny water flea, rescue crayfish, we have flowering rush, we have invasive Phragmites. So I just don't want you guys to think that, oh, they're only dealing with zebra mussels. We are not. However, I would say with the arrival of zebra mussels, these other species have taken a large back seat to our fight with zebra mussels, because those are sort of the dominant driver for our program because of the severe economic, social, and environmental costs zebra mussels can have on Manitoba. So just so everybody knows, we do have other things in the province, but we are, the focus is primarily zebra mussels at this point. So again, this is something good for Alberta, is that I would say my top advice is do what you can for as long as you can to keep zebra mussels out of your province. So just maybe touching on now, switching gears totally to zebra mussels now. I touched on this a little bit earlier, but just to sort of tell you guys sort of the two main phases of zebra mussels. So this is more for communication. So there is more stages of zebra mussels, but just to break it down to make it simpler, we broke it down to two. So essentially we have the baby phase, which we call the veliger stage, which is free floating. So they cannot swim on their own. They don't have appendages or arms. They essentially move with the water current. But I say the most detrimental thing is that they're completely microscopic. So you cannot see them in any water without a microscope. Veligers cannot attach to surfaces, unlike their adult phase. So they actually will just move with the water currents. They'd be moved in things such as bait buckets, live wells, anywhere you have water that you've moved from an invaded water body to an uninvaded water body can now spread this multi-million-dollar threat to a new area. So I'd say the veligers are probably the most concerning phase of zebra mussels because you cannot see them. The good thing is that veligers die quite quickly out of water. So essentially, if you may have heard sort of the slogan for aquatic invasive species: clean, drain, dry. The drain is to get rid of the water, essentially, and that will kill the veligers if the water is removed, and of course everything is dried. So a veliger, essentially in about 2 to 3 weeks, it goes from that free floating phase, and now it has to attach to a surface. It's building its shell, and now sort of going into the adult form. So we just, again, for communication's sake, an adult is a shelled version of the zebra mussel. It can be the size of a grain of sand, and it can grow up to about a little bit bigger than a thumbnail, just to sort of show you the range of sizes. So I would say, unfortunately, when you talk to people, even in Manitoba, about zebra mussels, they'll say, oh, I checked my watercraft, I have nothing on it, because they're all looking for the fully grown, easy to detect zebra mussel. No one is looking for that tiny, teeny, tiny grain of sand where you might not see it, but you could certainly feel it with your hand. So we tell people to, for example, to run your hand along the hull of the watercraft, especially if it's been moored in an invaded water body with zebra mussels. And you might not be able to see the zebra mussels, but you could certainly feel them. So this is one of the dangers I'd say about adult zebra mussels, is that they can be very small. So adults, once they have that shell, they also have something called byssal threads. So I don't know if you could see on this bottom picture here with the pencil, these are some zebra mussels I took from Lake Winnipeg, and on the very front of the zebra mussel, you can see some byssal threads there. Those are what makes zebra mussels attach to a surface, and they attach super strong. And if they don't like where they are attached, they can dissolve those threads, crawl somewhere else, and reattach. I'd say a very concerning thing with adult zebra mussels is that they can survive up to 30 days out of water, depending on temperature and humidity. So especially in the spring and fall is the most concerning times of the year, because that's when temperatures are lower, humidity is higher, and they essentially just seal their shell and easily just survive. So this is why the movement of watercraft over land is the #1 vector spreading zebra mussels around, because easily you go anywhere in North America in 30 days and take zebra mussels with you. So this is the main concern for us. So now just switching gears here to sort of part 2 of the presentation here, talking about the timeline and the spread of zebra mussels in the province. So here is, of course, Manitoba. For the people who are geographically challenged, I actually will highlight where zebra mussels are located. So they were first found in the South Basin of Lake Winnipeg, which is now circled on the screen here, in 2013 in the fall. In 2014, Manitoba undertook a harbor treatment where we used potassium chloride, essentially potash, and we tried to actually eradicate zebra mussels out of where we thought were the sort of the 4 hubs of where they were located. The treatment was successful. It killed all the zebra mussels in that treatment area. However, after the treatment was complete, we found zebra mussels in the middle of the South Basin attached to floating debris or wood. So we knew we did not get all the zebra mussels, and now we were just essentially trying to go into containment phase, and eradication was no longer an option. So, and even if in hindsight that treatment was successful completely and eradicated zebra mussels, unfortunately in June 2015, zebra mussels arrived into Manitoba via the Red River, which is an international water body that essentially borders borders North Dakota and Minnesota, the United States. So they are coming up the Red River into Manitoba that way. So we now have, because of the Red River, a constant supply of zebra mussels coming into Manitoba and into Lake Winnipeg. So there's a star on the very bottom of the screen there on that map that sort of shows, that's Emerson, Manitoba. That's the first part of where the Red River enters into Manitoba. So unfortunately now, because the Red River flows north, we now have zebra mussels coming into Lake Winnipeg. And also just to give sort of a difference between Alberta and Manitoba. I mean, Alberta, you guys have water bodies. Manitoba has maybe a little bit more. And also it's a little bit of a challenge because Lake Winnipeg has such a huge drainage basin. When you think about sort of the challenges when it comes to AIS in Manitoba, you got to think about Lake Winnipeg basin drains a small part of BC, a large part of Alberta, Saskatchewan, Montana, North Dakota, South Dakota, Minnesota, Northwestern Ontario, and Manitoba all drain into Manitoba and are 100,000 water bodies, primarily into Lake Winnipeg, and then goes out the Nelson River into Hudson's Bay. So Manitoba is the end of all that. So essentially we have to be concerned about anything that is moved or introduced in these areas, because unfortunately for Manitoba, water flows to us, and now we'll have those concerns. So fortunately for Alberta, though, is that zebra mussels will not make it to Alberta without human help, because the water bodies all flow to Manitoba. So that's one good thing for Alberta there, is that you will not get zebra mussels from the movement of water flow from Manitoba. So thumbs up for that one. So here, just to show you some of how fast zebra mussels can establish in a water body. This is our substrate sampler here that we use primarily for monitoring adult zebra mussels. Zebra mussels love PVC plastic, so we put 4 of these plates together and make a substrate sampler. We place these in water bodies around Manitoba now, so that we could actually see the presence or absence of zebra mussels in these water bodies. Essentially, they're a glorified dock. I mean, the dock will do the same thing. You could look at the underside of a dock and see if there's attached zebra mussels there. So, which is, I think everybody should do that anyways at this point. This is early detection. So if you take your hand and run your hand along the bottom of a dock, just check for anything that doesn't move and make sure it's not a zebra mussel. A great thing to do and get into that habit. So here is a substrate sampler before, what it looks like with no zebra mussels on it. And this is what the substrate sampler looked like, I guess, after 3 months in Lake Winnipeg back in 2015. And it's completely covered or stuccoed in adult zebra mussels. So also just to show you how the numbers have increased with zebra mussels, we took some veliger samples in Lake Winnipeg in 2014. So again, veligers are the microscopic form. So we took a water sample from the south basin of Lake Winnipeg. We took essentially a zooplankton net and we filtered 1,000 liters of water. That's sort of the standard way we take a sample. And so in summer 2014, we had the maximum amount of 25 veligers in a single sample. So fast forward to that to 2016, the same sampling protocols, 1,000 liters of water in a zooplankton net, took the same sort of sampling method. In 2016 in the fall, that number had increased to 87,000 veligers in a single sample. So it went from 25 veligers to 87,000 veligers in one sample. So essentially, prevention is the best defense for Alberta. Alberta needs to do whatever it can to stop this from happening because once you get these things, we cannot go back. They're hard to and difficult, if not cost prohibitive, to eradicate once they establish. So prevention is the best defense. So going back to the timeline here, so in 2015, we thought maybe Manitoba was out of the woods. We now had zebra mussels coming up the Red River into Lake Winnipeg, which the Red River flows through Winnipeg and enters into the south basin of Lake Winnipeg. We started finding veligers in the north basin of Lake Winnipeg. And then we got this. We got Cedar Lake. Cedar Lake is that circled lake on your screen right now. We found a couple of veligers in this lake. This was completely preventable and did not need to happen because the flow of water flows from the Saskatchewan River into Cedar Lake and then into Lake Winnipeg. So this would never have happened without human help because of the direction of water flow. So this is completely preventable. And so this is what we're trying to tell people, is that Cedar Lake did not need to become invaded, and this was done completely by the help of humans. So again, people did not follow the proper steps, clean, drain, dry. So that was unfortunate for Manitoba. Another sort of main challenge for Manitoba is that all this was happening. Zebra mussels came into Manitoba in 2013, and it wasn't until 2015 did Manitoba have provincial and federal aquatic invasive species regulations. So I think that was a little bit of a detriment for Manitoba, is that we didn't have the law on our side when this whole thing is starting to happen. So again, a benefit for Alberta that you already have your laws in effect. So I think that will also help you in the long run. This is also something for Manitoba, lessons learned from Manitoba. So here, now we had veligers found in the North Basin in 2015 of Lake Winnipeg, and now 2 years later, we found them in the North Basin, adults in the North Basin of Lake Winnipeg. And then because of the flow of water, again, the water flows from, Lake Winnipeg flows north. The Nelson River is the only outlet for Lake Winnipeg. So we did find zebra mussels in the lower reaches of the Nelson River in the summer of 2019. And this summer, 2021, they have now established within the entire Nelson River, and now they're to Hudson's Bay. This is not surprising because, again, the flow of water brought zebra mussels from Lake Winnipeg to the Nelson River. So although completely unfortunate there in the Nelson River, this was not preventable because of the water flow. So now I'm just gonna take a minute here. I'm not sure if everybody's maybe seen this. This is sort of the classic invasion curve here, and it sort of shows how, I mean, I guess people working with invasive species works on sort of an invasion. So just to give you some, just to walk you through this graph here. So on the x-axis here, we have time, and then on the y-axis, we have areas infested. On this axis here on the left, and on the right, we have control costs on the right. So you can see here, this is, for example, when it comes to Alberta and zebra mussels, you guys are sitting here in this prevention phase right here, which is key, and please stay there. This blue arrow here is sort of the introduction point. And then so you can see here, it goes from, you know, the eradication portion here. As you can see, the small number of AIS can start to establish here, and you can see how the numbers start to increase on this graph. So eradication is sort of the very first part. You want to see what you have and see if eradication is possible. So you have a small number of an AIS, and that's sort of what you need to do at that point. When the numbers start to increase and maybe eradication is no longer possible, you now shift to containment. And then after containment, it's essentially long-term asset protection here. I would argue that in Manitoba, we don't really have a defined containment stage. I would think our containment stage is from the very point of seeing an AIS in a water body all the way till, I guess, forever, essentially, because we want to contain the spread to that invaded water body. So containment for us doesn't stop. So for example, even, you know, having zebra mussels in Lake Winnipeg, the Nelson River, we're now focused on working with communities in and around those water bodies to prevent the spread to other water bodies in Manitoba. So for Manitoba, the containment never ends. It essentially starts with the introduction and continues on essentially forever. So if we put on here what's happening in Manitoba here, I'd argue that Lake Winnipeg is deep into the asset-based protection and long-term management phase of this graph. The Nelson River is, because it's unfortunate, I mean, the water is, it's a huge river. Eradication is essentially impossible for that size of that river. That I would say both of these water bodies are essentially into the asset-based protection long-term management phase. Again, we are working with communities to prevent you know, their watercraft from being fouled, from spreading to other water bodies, but these two water bodies are now in sort of long-term management. So now going back to the timeline here, again, Manitoba didn't get a break this summer. In the spring of 2021, we found zebra mussels in Asien Lake. Asien Lake is very close to the Nelson River. So we maybe think that some fishers moved zebra mussels from the Nelson River to Asien Lake. And so now we have another water body in northern Manitoba, just north of Thompson, Manitoba, that now has an establishing population in that water body. So I guess we thought, Manitoba thought we were out of the woods, and we thought, you know, please, nothing else could happen this year. And then of course we got this news from, we did some, a colleague of mine did some sampling in Lake Manitoba, and now we have found veligers in the narrows of Lake Manitoba. So here is Lake Manitoba, it's circled on your screen. There's a little constriction here, Lake Manitoba, that's called the narrows. A very popular place for fishing. Lots of, and that water looks like the ocean. It's a super blue and turquoise water, so very popular for people having cottages. People go fishing, and so we found veligers in Lake Manitoba there. So now we're undergoing our sort of early detection and our response at this point. We're trying to determine the extent of these mussels, or the veligers, at least in Lake Manitoba. We're trying to see how far north, south they are, to see if we can contain them. And we're just trying to, I guess, essentially figure out if eradication is possible. So we're still in that very early stage right now, just determining what our next steps are. So I apologize, this map is quite fuzzy, but just it sort of summarizes where we have zebra mussels in Manitoba right now. So again, we have them in the Red River, which is that river coming from the United States up through Winnipeg, up into the South Basin Lake Winnipeg, all of Lake Winnipeg, the Nelson River. Here's Asien Lake up here. Cedar Lake, unfortunately, we now got some other detections as the mussel veligers in Cedar Lake. We have not seen any adults, but again, these water bodies are huge. It's like finding a needle in a haystack. And then now, unfortunately, we're now finding some veligers in Lake Manitoba, primarily around the Narrows here in that small area right here. So this is where the mussels are currently located in Manitoba. So now you're thinking, oh my God, what is Manitoba going to do? So what we do here is, again, containment and prevention, again, and we're still working on those things, preventing introduction into new water bodies and containing the spread out of the water bodies that we have where the mussels are present. So this is what we're doing here. This is showing the watercraft inspection program. So you can see here the yellow stars indicate where the stations are located. So this program runs from early May until October. The stations are located on highway pinch points. We're trying to intercept the most amount of highway traffic carrying or transporting watercraft over land coming from, again, the mussel invaded water bodies. So I overlaid, so here's the yellow stars here showing the locations of the water inspection program. And as you can see here, a little map shows where the mussel invaded water bodies are. So we're trying to contain the spread of the mussels out of Lake Winnipeg from going further west. And so we have that line of defense, I guess, through Highway 6 here that goes through Winnipeg, Ericsdale, Grand Rapids, so we could catch watercraft moving before they go west. Because of the Nelson River becoming invaded, we tried to relocate the Swan River station to a place called Wabodin, which is on the Nelson River, essentially. We're trying to move that location to be nimble enough to work with the invaded water bodies of the Nelson River and work with communities up there to give them a way that they could actually decontaminate, because coming out of an invaded water body in Manitoba, you need to do clean, drain, dry. In addition, you need to decontaminate your watercraft and all your gear. So the watercraft inspection program there, located in Manitoba, is there to inspect watercraft and decontaminate as necessary. So we tried moving our station this year to Wabodin to help with the Nelson River. And again, this is one of the challenges that Manitoba has, is that I was in Wabodin last summer and there was lots of support to move a station there. But then when push came to shove and we tried moving the station there, no one applied for the position. So we spent months looking for people to staff the station, and we essentially didn't get any. So this is one of the, one of the challenges for Manitoba, is that people are saying, Manitoba, move a station, we move a station, and then it never opened. So this is some of the challenges that Manitoba has. We're going to continue trying to staff the station, hopefully next year, but this is some of the things that Manitoba is dealing with to try and contain the spread from invaded water bodies. So back to Lake Manitoba here, what are we doing with this? Again, this is one of the newest detections that we have. And so what we're doing here is that we now have, in Manitoba, we have things called control zones. So Lake Winnipeg, the Red River, is part of a control zone, which again means when coming out of that water body with a watercraft or water equipment, you need to clean, drain, dry, and you must also decontaminate before going to a different water body. Because this Lake Manitoba invasion is so new, we put restricted access signs around Lake Manitoba. So now essentially, in addition to doing clean, drain, dry, if you're leaving Lake Manitoba, you must also decontaminate. So we're again trying to contain the spread of the mussels to Lake Manitoba so they don't spread further afield from that water body. So in addition to that, we've we're launching in the next day or two, I'll say for Manitoba at least, a massive communication campaign. I essentially provided my entire communication budget and said, put it on this campaign here, just to make sure people are well aware what the requirements are. So I guess in the past, Manitoba has taken a stance on communications to sort of be, polite and positive and like, you know, are you moving your watercraft? Please clean, drain, dry. But this time we're taking a different communication stance and doing a little bit of finger waving and sort of saying it didn't have to be this way. Someone did not clean their watercraft. Someone didn't do the right steps. This could have been prevented. So that's sort of the tone of the new communication campaign being unveiled, to sort of make people wake up and say, you know, this did not need to happen. So this is what we're working on, or I'm working on right now, is a massive communication campaign for Lake Manitoba. I'm just looking at my notes and making sure I didn't miss anything. So back to this invasion curve here. So I would say for Lake Manitoba, we're sort of in the middle of the eradication containment phase right here on this graph here, because the population in Lake Manitoba is small at this point for zebra mussels. So again, we're trying to do some additional monitoring to see what we're looking at here, to see if we can contain it and see if eradication is possible. And then again, containment, we're doing the containment phase anyways. So that's where now watercraft needs to be decontaminated if leaving Lake Manitoba. So I'd say on this curve, Lake Manitoba is located here, that we're still sort of really in the early detection and response phase of this water body. Okay, so now, I think I pretty much gave everybody the gloom and doom outlook here for Manitoba. So again, what I'll do here at the end is maybe summarize what some things that Alberta can do, and to maybe avoid some of the challenges or pitfalls that Manitoba has fallen into. And let's just see, overall, I think Alberta is in a much better position, and this is some of the reasons why. To prevent the introduction of zebra mussels into the province. And just, I think, compared to Manitoba, Alberta is definitely in a better spot than Manitoba was when we first got zebra mussels. So, and here we go. Here are some of my lessons learned to Alberta. In 2013, like I mentioned earlier in the presentation, our focus changed from, I remember back in 2013, we were looking at, eradicating rusty crayfish, or sorry, not eradicating, reducing the population of rusty crayfish in a lake in Manitoba. That all changed when we got zebra mussels. As soon as zebra mussels hit the province, all those other species that we have taken a huge back seat, and zebra mussels are now the #1 focus in Manitoba. So that was a big change for Manitoba right there. Also, to Manitoba's detriment, I guess, we were the very first Western province outside of Ontario to get zebra mussels. So I would say we were the guinea pigs when it came to zebra mussels, because looking at some of the things that Ontario had to prevent, zebra mussels from establishing in pipes. Ontario was given special zebra mussel sort of permissions, and Manitoba didn't have that. So we kind of had to work with the federal government and say, hey, zebra mussels are now in Manitoba. We need some of these sort of permissions to do things in our province. So I'm hoping that Manitoba may have paved the way for other provinces. They don't need to go through those same steps and be that guinea pig. So I'm hoping that it will benefit our Western partners in Canada here. But overall, I'd say that Alberta, the benefit is you could learn from Manitoba's experiences and avoided our pitfalls. I think is probably the best thing I would say for Alberta, and you guys are already doing that. Another point here is that, again, Manitoba had aquatic invasive species laws under the Provincial Water Protection Act and under the Federal Fisheries Act. 2 years after we had the major threat within our borders. So that was a major challenge for Manitoba, because we didn't have the tools in our toolbox that we have today. We did not have that when zebra mussels hit our province. So I think it might have been a little bit different if we had those laws in effect first. So again, Alberta, thumbs up to you. You guys already have laws in effect, so you guys are already ahead of the game there. I also would say that Alberta, the fact that you guys have been working on building awareness, communications, and buy-in for the general requirements, clean, drain, dry, with all Albertans. You've had several years to do that because changing behaviors takes time. And so I think Alberta's a leg up on that, which again, Manitoba, we did not have that luxury of having that time to build up awareness. We had the threat in their backyard, and we were trying to communicate to the public what they need to do. So overall, Manitoba, we are continuing to work on changing long-term behaviors. Meanwhile, we have a threat in our backyard that is operating on very short term. So that's a huge challenge for Manitoba. So again, Alberta, you have the leg up because you are already building that communications and those buy-ins, and that you're changing behaviors well before you have the threat in your backyard. So I would say that is a huge advantage for Alberta right there. And so continue to do that. For Manitoba, again, we were the guinea pig. We have zebra mussels, the first province in Western Canada of zebra mussels. So we went it alone with Lake Winnipeg. Now, I'd say, thank goodness, we have our friends to help us. We have worked, we have something called the Interprovincial and Territorial Agreement for the Coordinated Defense Against Invasive Species. Quite the mouthful. Essentially, Manitoba now has its friends, Saskatchewan, Alberta, BC, and Yukon, and we're all working together on invasive species. So we're not going it alone anymore. We all have been trained on incident command systems, so we all can work together. And if there's a major incident in a province or somewhere territory, we now have this training, and we could all sort of band together and help as needed. So again, this is also a benefit for Alberta that Manitoba did not have this luxury at the time when zebra mussels hit our province. And again, this is probably one of the big ones I found, is that Manitoba Manitobans, I'd say, are quite reactive. And I remember presenting in Alberta several years ago on zebra mussels, and I was blown away about how proactive Alberta was, meaning that, I remember, this is probably like 5 years ago, someone in Alberta said, hey, Manitoba, we will buy you decontamination units. This is what Alberta said. We'll buy you decontamination units. You just do what you need to do to keep the mussels in Manitoba. I was absolutely floored. So Alberta is very proactive. I'd say high five for that. Continue to do that. You guys are prepared. You have the laws. Manitobans, I would say, are still a little slow on the uptake when it comes to knowing what to do. And obviously, zebra mussels are spreading in our province. So Manitobans tend to, in my opinion, wait for the Manitoba government to, sort of do the heavy lifting. And I find in Alberta is that you guys are recognizing or realizing everybody needs to do the heavy lifting to prevent this from happening. So I would say that's one of the biggest benefits for Alberta. And if I could say anything, the most important thing is prevention is Alberta's best defense. Defend your borders. Keep the threats outside of Alberta, because that will make your lives super easy. Because once they're in your borders, as you've seen from Manitoba, we now have to worry about the spreads inside our borders, plus everything else flying at us, any other AS, anything coming new into the province, like Asian carp or invasive carp, quagga mussels. We also, so essentially defend your borders and prevent stuff from coming in will make your lives easier. So do what you can to continue the prevention efforts, and that will help you in the long term. Also, some other lessons learned is that, again, now the help of the federal family is evolving. There's now, Fisheries and Oceans Canada is now in the landscape. It really wasn't there when Manitoba, first hit Manitoba. We also have Canada Border Services Agency. It's more proactive and working very well with Alberta. Manitoba has worked with CBSA in the past, and our relationship has been a little bit rocky because, we used to defend our borders, our southern borders, from zebra mussels from the United States, but because of having that major threat inside our borders, we pulled back from the borders, and now we're trying to defend our water bodies inside our borders. So it's been a little bit challenging working with CBSA or Canada Border Services Agency, but Alberta, you guys have a great working relationship with them. So again, thumbs up to you guys. You guys are very well poised to prevent introductions of zebra mussels into your province. So this is sort of my summary slide here, which for Alberta, again, for Manitoba, it's stop the spread. Alberta, stop the introduction. Do what you need to do to stop the introduction of zebra mussels into your province, because that will save the province money, lots of money. Zebra mussels are here to stay in Manitoba, and this is one of the things I'm trying to convince Manitobans is that, people will say to me all the time, how long are zebra mussels here for? And I said, I keep on telling them that zebra mussels are here to stay, especially if they're establishing in a water body, such as like Winnipeg. I said, they'll be here to the next glaciation. Like, humans will be gone, the mussels will still be here. So we are looking at ongoing perpetual costs of these mussels onto Manitoba forever now, because we cannot eradicate these mussels out of our water bodies that are now invaded or are becoming invaded. So Alberta, do what you can to stop introduction. Again, AS, the spread of AS or introduction of AS is completely preventable, and it's humans that are the primary spread of zebra mussels into different water bodies. Unfortunately for Manitoba, we do have connected water bodies, and so we are a little bit at a detriment right there, but humans are, again, the #1 vector spreading it. So again, that's where you need to target to prevent this from coming into your province. And this is my mantra. I'm not sure if it's very successful, but working on aquatic invasive species requires collective action and is a shared responsibility. And so until everybody realizes that, this is the challenge that Manitoba has, is that it will take everybody working together to stop this from spreading. Again, I always tell people I don't have a superhero cape in my back here. I can't do this alone. So we need everybody to roll up their sleeves and stop the spread. Do clean, drain, dry, decontaminate when necessary. This will prevent the spread, but people need to take those steps. And for Alberta, Manitoba's here to help. So we've already been going through this for now 8 years in Manitoba. So fingers crossed that Alberta doesn't need to ever experience this, but please be prepared. And again, defense, preventing the introduction is your best defense in Alberta. So with that, that's my lessons learned, and that's the end of my presentation. I'll take any questions if anybody has any questions.
That was great. Thank you so much for that presentation. It's been interesting over the past year. We did have a kind of a stewardship campaign, letter writing campaign to our minister to re-inject some funding into our highway check stops.
Mm-hmm.
So thanks to anyone on the call today who participated in that and is focused on those prevention efforts. And I've seen recently too, municipalities purchasing their own decontamination stations to protect their water bodies. So there is ongoing effort, and I hope that we don't enter a place where we get just a bit complacent because we keep looking for them and we haven't found them. So thanks to everyone who's continuing those efforts. So we do have a couple questions coming in. I think you might have addressed this one a little bit, but Tristan is asking, are you working cross-national border on the prevention of AIS, and what are areas that could be improved in this effort?
So of course, we are working with, of course, the Western provinces and Yukon. So when working with, I guess we have some challenges working with the states. Like for me, for example, what we have is, in Manitoba, as an example, like when a watercraft is decontaminated, we have essentially, it's called a seal. Essentially, it's a zip tie, but we put, once the watercraft has been decontaminated by the Manitoba government, we put a zip tie around the front of the watercraft, and that attaches to the trailer. So when that zip tie is connected, we know that watercraft has been decontaminated. So one of the challenges that we have is that, for example, we have lots of Americans coming up to Manitoba to go fishing, right? So I was so happy when the border was closed. Now it's unfortunately opened. So we have, people coming from Minnesota, which also has a lot of AIS, things that we don't have, including invasive carp. There is some concern with them coming over the border. They don't have that seal kind of system in Minnesota. So we're relying on Canada Border Services Agency to, turn watercraft away if they're not clean, drained, and dried. So this is sort of an ongoing challenge effort that we're working with to try and defend our southern border from people coming from the States. Yeah, in North Dakota, which is all again south to Manitoba, their program, they've taken a different sort of stance on this. They don't really have any watercraft inspection programs. So it's a little bit challenging to see the differences between the states, but we do work with them. But I'd say one of the biggest challenges is defending our southern border from Americans coming in and bringing new things to us.
Interesting, yeah. Richard's asking, do winter temperatures have any effect on the zebra mussels?
Unfortunately not. Zebra mussels will start spawning at 12 degrees Celsius, which is but around Lake Winnipeg, we have found, my colleague has found live zebra mussels actually within ice on around Lake Winnipeg, and they were still alive. I think she collected them thinking that they were dead, and then she put them in her office, and then a couple hours later, and they're still moving. So, unfortunately, zebra mussels are not going to be affected by our temperatures. And just as more of it's kind of scary to think that zebra mussels have a cousin called the quagga mussel, a different species, same, kind of look the same, a little bit bigger, but they actually prefer even colder temperatures. So, zebra mussels do well in Manitoba. Quagga mussels will do even better. So unfortunately for Manitoba, cold temperatures are not going to deter zebra mussels or quagga mussels from surviving in this province.
Yeah, I was wondering about quagga mussels when you were speaking.
Yeah.
Lauren's wondering, in order to invoke systemic change and understanding to help prevent the spread of AIS, do you think that targeting young people in the awareness and citizen science initiatives would be beneficial in the long run? And are there currently initiatives targeting that audience?
That's a great question. I think Manitoba's major challenge is that, and this is different from Alberta, because Alberta, I would say, target the young people in Alberta. Manitoba, we are kind of, if we had the benefit of having a longer time to sort of provide education to the public, without having zebra mussels in our backyard, I would say yes, do the whole gamut of communications. I don't, in Manitoba right now, we're worried about boaters moving, like we also float planes moving. Kids don't drive boats and float planes. So we do have, for example, I think Alberta is using, we did a activity coloring book, which our former minister wanted us to make, but I don't think that hit the target. That would be great. We'll see those benefits, in a couple of generations, or a generation, 15, 20 years, you might see those benefits, but we don't have that luxury of time right now. So I say Alberta, yes, go ahead with communicating to the young people. Manitoba, we're doing a little bit about that, but we don't have massive amount of staff, so we need to be focused and strategic. So we are targeting essentially the vectors, which are primarily adults with watercraft, float planes, and what have you, to prevent the spread. So for Alberta, yes. Manitoba, not so much right now.
Jackson says, thanks for the presentation. Do you use any models or resources to predict the movement of mussels as an additional proactive step at tackling AIS?
Well, we do have the watercraft inspection program. So that's sort of essentially what helps us to determine high risk water bodies. So, when people stop at the watercraft inspection program, we ask, where they came from, because that's when we need to know, do they need to be decontaminated, and where they're going. So all that information is documented. So we know, for example, for several years now, we have known that Lake Manitoba may have been a high risk water body because just of people saying, I'm coming from Lake Winnipeg, an invaded water body, coming to a station, and they're saying, I'm going to Lake Manitoba. So we do have that data that kind of helped us to determine what are higher risk water bodies.
And when you look at that data, do you see a lot of folks coming from Alberta or returning to Alberta?
That would be something that I need to dive deeper into. That'd be my colleague Kayla, who oversees a watercraft inspection program. And that's something I could look into or ask her, but I don't know off the top of my head, no.
And I guess Alberta would have similar data from our own highway check stops as well. So, Richard's wondering what is used to decontaminate a boat?
Super easy. It's hot water. So essentially, we're trying to cook the AIS to death using hot water. We don't use any chemicals, no soaps. Essentially, 60°C water at a close range. The first step is to doing a low pressure rinse first throughout inside out the watercraft as well as the equipment to essentially we want to kill first, and then if we need to remove second, and always in that order, because we don't want live sea mussels from falling off a watercraft and go into a drain or fall into a water body. So we do low pressure, high temperature water rinse first, and if necessary, pull out the high pressure to remove anything. But I would say about 90% of watercraft in Manitoba essentially is just the low pressure rinse, and we very rarely take out the high pressure because most people are hopscotching so fast from one water body to another. Alzimals are not attaching yet, but if watercraft are moored in a water body for longer periods of time, that's when you would probably need to take out the high pressure one to remove. But essentially, hot water is all you need.
And I was kind of thinking during your presentation, what is the conversation around just completely quarantining off some of these more isolated lakes? Is that a conversation, or is it just too, politically that would never fly if you just said no more boats in or out?
Well, for the size of the lake of Lake Winnipeg, I think that would not be possible because we have, commercial fishers in there. It's the largest commercial fishing fleet outside of the Great Lakes is in Lake Winnipeg. So, people said to us, close all the boat launches. I would love to close all the boat launches. But yes, politically, no. But as an example, there was a lake that we had in the Duck Mountains in southwestern Manitoba, in Duck Mountain Provincial Park, called Singoosh Lake. Essentially, it was a smaller water body where we actually detected zebra mussels in that water body. So what we did is that we prevented any day use boaters from going into that lake for 3 consecutive years. So people couldn't drive to that lake and launch, is prohibited. Anybody that had a cottage around that lake were able to launch. We provided them with a control order that said you could launch in this water body, but essentially once you launch into Singoosh Lake, you cannot launch anywhere else open water season. So we essentially did that for 3 years. We essentially did what you said, Brad. We contained that lake for 3 years, and then during that time we did continue monitoring, and after 3 years we didn't find any zebra mussels, so we lifted the ban, and so Singoosh Lake just opened up last summer for the first time. So we have done that for smaller, Singoosh Lake is much smaller, but we have done that in the past.
And is there any efforts to apply a potash treatment on some of these smaller, more isolated lakes?
And that's something that I guess we're in discussion with. Like it would depend on, of course, the size of the lake, how connected it is to other water bodies. So a whole bunch of other factors would have to go into that. So that was something that we could totally consider. And if needed, it would be, again, so I'd say something different from Manitoba and Alberta is that Manitoba has quite a small population. We have unfortunately, a lot more water bodies than Alberta does, and a much smaller population. So resources and budgets are also, I'd say, a challenge for Manitoba. So that wouldn't be off the table, but it definitely had to be sort of the perfect situation for us to do that.
Right. 2 people are asking about any programs that you have to work alongside Indigenous communities to help educate or participate in surveillance for zebra mussels?
Yeah, so along the Nelson River, there are several Indigenous communities around the Nelson River that we are, I guess, working with or trying to work with because of the Nelson River is becoming invasive zebra mussels. So we are sort of reaching out to the different communities and sort of seeing what their needs are. There is a community where we are actually purchased a decontamination unit for them. So we're working with them to get them trained up. There's also a community called Norway House, sort of on the more south on the Nelson River. And then actually I went up there last summer and did level 1, 2, and 3 watercraft inspection training. And so now they've been fully trained by the Manitoba government, and they're actually doing their own decontaminations through their own program, because they are trying to protect another watershed beside the Nelson River watershed. So we are working quite closely with Indigenous groups to ensure they know what to do to prevent the spread, and so that they could learn what they could do to make sure that they're not spreading zebra mussels to other water bodies. That's definitely an ongoing project for Manitoba.
Great. Kayla is wondering if the velagers are found in any specific part of the water column. She's wondering about when you were talking about those zoo net halls. Are they?
Yeah. So the velagers are essentially so zebra mussels, like I mentioned earlier, they start spawning at about 10 to 12 degrees Celsius. So they are water temperature specific. So Manitoba, that's how we start our monitoring, is that we'll start monitoring when temperatures reach that, because that's when zebra mussels start spawning. So we have learned over the last 8 years when's better time to sample. So we have, we do some spring sampling, mostly summer sampling and fall sampling for velagers, because it does, of course, the longer the season is, because these mussels can spawn more than once in a season. So we have perfected the when to monitor based on temperature in the water body. So yeah, it definitely is temperature dependent, and you probably find them more easier and longer in the season than the beginning of the season.
Okay, we just have one last question here. Does the potash treatment affect other species?
Great question. So the reason we use potash, one, it was a more economical option. So potash was potassium chloride. So it was essentially and I don't know if anybody knows, but like Lake Winnipeg generally is quite algae laden in the summer. So we essentially fertilized the lake. That's what we did. So we did choose potash because it did have very low to almost no impacts on non-target species. So potassium chloride, so zebra mussels like potassium, and the chloride kills them. So that was chosen. So we found it was essentially, we were fertilizing the lake and didn't have detrimental impacts on non-target species, and that's why it was chosen for Lake Winnipeg.
Great. Okay, so those are all the questions. Thanks everyone for submitting those questions. And thanks, Candace. This is exactly what I was hoping to learn and hear from you. And I'm sure we could talk for hours about what's happening in Manitoba. But thank you for spending an hour with us today to share. And I hope it reinvigorates some folks to engage in some of these prevention efforts. So I really appreciate it.
Thank you very much for the opportunity, guys. Thanks very much.
Great, thank you. So we'll go ahead and switch to our second speaker for the day, which is going to be Caleb. So many of you probably already know Caleb. Caleb's been the program manager with ALMS for a couple of years now, and prior to that was a lake watch technician as well. Before joining ALMS, Caleb worked on projects at the university related to cyanobacteria monitoring and algal pigment analysis. So I'm really pleased that Caleb's put together all this information about our summer this year. It takes a lot of time to track down all the numbers of people we work with and lakes we work at, and it takes a lot of effort to put this presentation together. So thanks, Caleb, for doing that. And yeah, I can see your screen now. It looks good. So I'll just pass it over to you and let you take it away.
Great. Thanks, Brad. And can you hear me okay?
Yeah, sounds clear. Yeah.
Okay, perfect. Well, just start off by saying thanks to everybody for attending. If you attended our webinar series last year, like Brad said, I gave a similar presentation last year. So this one, it's going to be kind of an overview of what we've primarily been up to in the summer, which has been quite a few things. So, I'm sure most of you kind of know about us already a little bit, but to give some background about the Alberta Lake Management Society, we primarily exist to promote the understanding and comprehensive management of lakes and reservoirs and their watersheds. We are a nonprofit. We were formally established in 1991. So we've been in operation for 30 years, 30 great years. And we have a lot of activities, but we primarily do education. We spend a lot of time collecting and synthesizing information about our lakes. We provide scholarships to foster aquatic research in the province. We participate in local, provincial, national programs, and we also provide expertise to other organizations concerned with lakes and their watersheds. Now, just to give a quick overview of what I'm going to talk about, I'm going to first go over our Lake Watch and Lake Keepers programs, and then I'm going to get into what we've been up to for recreational water, rec water, beach sampling this summer, along with some additional eDNA research and analysis. I'm going to talk about some of the work we've been doing to validate satellite-based tools monitoring algal blooms. And then I'm going to go quickly over a little nutrient budget project we have at a lake called Little Beaver Lake. I'm going to talk about our monitoring efforts for Eurasian water milfoil, and then talk about our scholarship recipient very quickly. And this map just kind of shows some of the major programs where we've been distributed over the summer. So we've done a lot within Central Alberta, quite a bit as well in the Peace region, and kind of the programs didn't extend into Southern Alberta as much this year. But yeah, starting off with our Lake Watch program. It's our longest running program, 25 years we've been doing this program. So we made this special logo to kind of honor 25 great years of doing the Lake Watch program. And like Brad said, we've designed a t-shirt, and or we've made t-shirts with this design on it, and the lucky recipient of the draw will get one of these t-shirts today. So this program is our participatory science program. So it's the one where we hire technicians who work with us in the summer. They're trained to provincial government standards as to how to sample lakes, and then they go and sample a number of lakes across Alberta with the support of volunteers who provide their boat and their time and a lot of their expertise to help our technicians to sample these lakes. So our technicians meet these volunteers at their lakes 4 times throughout the summer. And the sampling follows the path of taking a profile at one location and then doing composite sampling at other locations throughout the lake. So this summer we sampled 26 different lake basins. That's a bit more than last year. If everything goes well, we'll have done 105 trips. So that means every lake has been sampled 4 times in one lake. We decided to do a 5th, and so far we haven't missed a trip. One of our technicians has already done all of her lakes, and the other is out at Burnstick today, and then she just has Crimson next week, and then that's it for Lake Watch. So it's been a really great season doing the sampling, and we've had a lot of support for the program this year. We've had a larger number of contract lakes this year, but yeah, we get support from Alberta Environment and Parks, Alberta Eco Trust, LICA, which is the WPAC for the Beaver River Watershed, and then the MD of Wainwright and Hardisty, and also the Pigeon Lake Watershed Association have all contributed to monitoring through the Lake Watch program this year. And our 2 technicians this year are Brittany on the bottom left there, and Carrie on the right. They've been amazing. They both had a great background in working with volunteers to sample lakes through other programs. So it was a really great fit for them to be part of Lake Watch this year. And yeah, our volunteers really like working with them, and we found it very easy to work with them as well. So thank you both to them for their hard work this year. And I think I'll just do a quick shout out to say, if any of you know people that are looking for possibly some short-term work next year, I guess over the summer, tell them to keep an eye out for our Lake Watch technician posting for the 2022 season. We're going to be posting it sometime in the winter. All right, so just to kind of go over what we've been seeing on the lakes through the Lake Watch program. Of course, quite a bit of smoke in July. A top left picture is Calling Lake. Is a photo that our technician Carrie took, and the other one was at Upper Man Lake. So yeah, it was probably like a fairly short part of the season where we had quite a bit of smoke, but at this point, we don't really know what it's meant for our lakes. We have some thoughts that perhaps it would have reduced some of the algal growth at the time, but we don't really have any data or have done any analysis to support that. And it's kind of hard to maybe factor in how the heat would have interacted with the smoke at the time. But anyways, we saw a lot of smoke out on our lakes this summer, which isn't that surprising. The next slide here, there's kind of two things I want to mention. The first is in the bottom left there, our technician is holding what was a Secchi disc. So for those who have done lake sampling, they'll understand sometimes you lose your Secchi disc. And this year we lost quite a few, which is kind of interesting. No other season have we lost so many Secchi discs. So it's kind of a funny thing for this season. But what I really want to show with these photos is this is at Gull Lake. And this photo was taken, the photo our technician took on the water there was taken in July. You can see that the color of the water is really bright blue, kind of milky. And at first glance, you might think it's a bloom, but it's not. It's actually what we call a whiting event. And in that satellite imagery, you can see Gull Lake there on the top right. It really sticks out as a bright blue, almost looks like a lake in the mountains, like Lake Louise or Marin Lake. And compared to Sylvan Lake there, you can see the difference in the color. And yeah, it's a whiting event, which is caused by the precipitation of calcium carbonate. And this, for the most part, this happens during a hot spell at the same time where algal growth kind of is starting to ramp up. So those conditions kind of change the chemical environment of the water such that calcium carbonate will precipitate or become a solid and kind of come out of solution. And it actually persisted for quite a long time. So it was first observed at Gull Lake in July, and our technician was out at Gull Lake on Tuesday this week, I believe. And it was still there, although she said that it's starting to dissipate. So it's kind of an interesting phenomenon to see. I think another lake in the province I saw from some satellite imagery also had a whiting event up at, it was Crane Lake. And yeah, for the most part, these aren't phenomenon that we're worried about. They don't cause any adverse effects. They're not toxic, but they're just something interesting that we see at lakes every so often. And the last thing I'll mention is that like every year we see cyanobacteria in our lakes. That's not all that surprising. But something that's kind of interesting this year is some of the lakes that we talk about blooms at the most, some of the ones that are more high profile, I guess, or just have a lot of folks living at them and are aware of blooms. We didn't actually notice the blooms to be quite bad at those lakes this year, which is kind of interesting. So again, we don't know if that has to do with smoke. It's surprising given the high temperatures earlier in the summer too. We would have anticipated that would have cued some of these blooms a lot earlier, but that's not exactly what we saw at some of at certain lakes. But other lakes still had very large cyanobacterial blooms, and some of our beach monitoring data through another program kind of indicates that some of these lakes that had these blooms, they ended up being quite toxic. So kind of a mix of lakes that had quite large severe blooms and other ones that didn't really seem to get to that point. So it's kind of an interesting observation that we have from our lake watch sampling this year. And I can't talk about summer 2021 without talking about the heat dome that we experienced in June, at the end of June there. So this top figure, I've just pulled some average air temperature from 3 stations. From the Battle River Headwater Station near Pigeon Lake, Glenevis near Lac St. Anne, and Tomahawk near Wabamun. The reason why I picked those 3 is because around the heat dome afterwards, we started getting some reports from volunteers and staff who have been at these lakes that, yeah, there were some whitefish kills at Pigeon Lake, Wabamun, and Lac St. Anne. I'm sure there may have been some fish kills at other lakes in the province, but these are the only ones that we've really heard about. They weren't too extensive. Talking to some folks at Pigeon Lake in particular, nothing like they saw in 2010, but nonetheless, there were large numbers of fish that died in this period. And it's not all that surprising given the temperatures. Whitefish are very sensitive to high temperatures and low oxygen, and that's exactly kind of what a calm hot spell will do. It will cause these lakes, these large lakes, to stratify briefly, and that will start to lead to oxygen dissipating lower in the water column, the temperatures in the surface waters to get very high, and this kind of squeezes the whitefish, especially the aging whitefish. They're really sensitive to this and will actually lead to mortality in some of them. So something that we observed this year. And kind of another interesting part of that observation actually is that we have this high frequency data collection happening at Pigeon Lake through this buoy. Actually some of the data that we're getting, the preliminary data that we're getting from this buoy that's collecting data from Pigeon Lake, both a lot of information at the surface, but then also temperature and oxygen through the column. Well, oxygen only really at the bottom of the lake. We're getting data from this buoy every 15 minutes, and it's kind of showed us that during that heat dome, there was this stratification and oxygen depletion in the bottom. So yeah, it's something that it's interesting for us to see these reports and to look at the buoy data, because with our Lake Watch program, we're not really sampling with high enough frequency to be able to catch some of these really quick stratification events, especially if our Lake Watch techs aren't out on the lake at that time. So it's interesting for us to look at this data, but I'll also say that this data is it's preliminary, it's unvalidated. We know that there's some erroneous data coming from it. And that probably has to do with some fouling of some of the sensors, and that our Lake Watch sampling is part of this validating, because our tech that's sampling Pigeon Lake is going to the buoy when they're on the water and taking a profile right beside the buoy, and then we're going to use that information to validate some of the data that the buoy is generating. So it's another kind of cool aspect of the Lake Watch season this year, is to validate this buoy. All right, so now I'm going to go into kind of what we're going to be focusing on when it gets to writing the reports and doing data analysis for Lake Watch. So that figure on the left kind of shows profile data for temperature and dissolved oxygen. And I think lots of the high temperatures that we've been seeing out on the lakes this year is kind of prompting us to start to look at a lot more of this temperature data that we have. We've been collecting this data for 25 years in the province, even longer, kind of back to the 80s. And just really anecdotally, kind of talking to one of the Alberta Environment and Parks scientists that we work with quite closely for this Lake Watch program, we've never seen surface water temperatures like we've seen this year. I can speak from experience. I was out on Pine Lake this summer doing sampling, I think right after the heat dome, or maybe even it was within the heat dome time. And the surface temperatures was something like 27 degrees. It was bath water. So we've seen some really high surface temperatures this year, and we're going to begin to kind of look at maybe how some of these temperatures have been changing over time for these lakes, so we have a lot of this data. So look out for that in our reports. And we're also going to spend more time looking into some of the ion data that we've been collecting, because we focus on 4 main parameters for our trend analysis. Total dissolved solids is one of them, which is kind of a sum of the ion levels that were in the water. So we want to try to further this analysis by looking at sort of the distribution of ions and which ones might be driving some of these increasing trends in total dissolved solids, because it's the parameter that we have been seeing to be the most commonly significantly increasing parameter. So we want to try to see if there are a couple of ions possibly driving these increasing trends in TDS, and possibly what the relationship between some of these trends are with lake water levels, which have been variable and generally down over the past 10 or 20 years. All right, so I'm going to now move on to what we've been doing for our Lake Keepers program. So Lake Keepers is a much newer program. The summer Lake Keepers program, this is our 4th summer doing it. It is our more, I guess you could say, purely citizen science program, in that we develop the materials and get all the equipment together and send off those things to volunteers throughout the province, and they actually are sampling on their own. So this year we have 9 lakes part of the Lake Keepers program. You can see from the map that they're primarily focused within the Peace watershed and a few in central Alberta. And it's really great to start to see some more really isolated lakes being sampled through this program, because that's what the program was designed for. Our Lake Watch program is really great for lakes that are close to Edmonton, lakes that are easily accessible by our technicians. But we realized that a number of years ago, when we were developing the Lake Keepers program, we needed a program like this to be able to access some of these more isolated lakes and lakes that don't otherwise have a lot of information. So the Lake Keepers program, each lake is sampled 3 times through the year. And at a single sampling location, there are surface samples collected that gather information on nutrient data, such as total phosphorus and nitrogen. Chlorophyll sample is taken. And if the volunteers observe bloom conditions, then they also fill up a bottle where we can quantify microcystin, which is a cyanobacterial toxin. Our volunteers are also taking temperature and dissolved oxygen profiles, and then other environmental observations, including a Secchi depth reading. So they've been doing that sampling for the past number of years, but something new for 2021 is actually that they're doing aquatic invasive species sampling. So we've sent out kits, extra net kits for them, and they're taking samples through the water column to try to detect these veligers that we learned about in the last presentation, which are the larval stage for these mussels. So it's really cool. It's really great that we can be taking these samples from the Peace watershed, because that region otherwise doesn't have AIS monitoring. So it's really great that we could add that this year to Lake Keepers program, and that was in support by Alberta Environment. And another thing that we've added this year, this is really going to become a focus for Lake Keepers moving forward, is we've added some protocol surrounding quality control. So we have our volunteers collecting some duplicate samples for us to kind of know for the surface grabs, is there a large difference between 2 bottles if they're doing surface samples, depending on how heterogeneous the surface of the water is. And we're going to continue to add some of these QC protocols, because it's something really important for these citizen science programs to understand the integrity of the data that you're getting. And that's just one of the first steps that we're doing, is to add this duplicate surface sample. And thanks to TD Friends of the Environment for their support for this program, along with the Alberta Conservation Association and the Mighty Peace Watershed Alliance. And I also realize I'm missing another logo of a supporter. It's a newer grant that we've got through Cabela's, actually. So thanks to Cabela's as well for supporting the Lake Keepers program. All right, so now I'm going to talk about another side project that kind of came from Lake Keepers. So if you remember, last year we talked about other lakes that were sampled in the Carvel Pitted Delta, which is this geographic region just west of Stony Plain and Spruce Grove. It's that kind of cluster of lakes that you can see. So last year we did some additional sampling at these lakes through the Lake Keepers program, and this year that project has been expanded. It has its own funding now through the Land Stewardship Center, as well as through Stony Plain Fish and Game. Then SWA and ALMS is contributing to the sampling, or to the program. And this year, it's Dave True, one of the board members of ALMS. He's working alongside some folks from the Alberta Lake Management Association to sample a lot more of these lakes. It's a really cool program, because it's gathering data from lakes that have never really been sampled before. The large majority of them are unnamed. So it has a really cool aspect of gathering information for lakes that have never been sampled before, to help the municipality and stakeholders understand sort of the diversity of lake conditions that we have in that region, because we have really shallow, high nutrient lakes that get quite productive in the summer, but right beside them, kind of over the hill, you have lakes that are deeper than Wabamun and Pigeon, and that have nutrient levels that are similar to what we see in some mountain lakes. So we have quite a diversity of lake types in that region. So it's really interesting for us to kind of capture that diversity. And there's also like it's also interesting in that the only way that that Dave and some of the other folks that are getting onto these lakes is through private land and kind of interacting with these landowners who have their land on these lakes. And it kind of starts a conversation about private land or private lake stewardship. And that's to say that, you know, these lakes aren't owned by these folks, but they own the access and land surrounding these lakes, and that they have a large stewardship aspect of these lakes. And a lot of them are really interested in knowing how to be better stewards of these lakes. So it's really, the program is really kind of interesting from that aspect. So these lakes just have a single sampling event. They have a surface nutrient and chemistry samples taken. There's a bottom nutrient sample taken as well. And then there's also some biological samples collected. So we're getting phytoplankton or algae samples, zooplankton, as well as some benthic invertebrates. And then temperature, dissolved oxygen, pH, and conductivity profiles are also collected. So once the season is done for this project, sampling is still occurring. And once it's done, it'll probably be somewhere in the ballpark of about 40 lakes that have been sampled. We're going to compile that data and then release a report of some of the data that we're getting from this project sometime in 2022. And for that project and for lake keepers as a whole, you can find all of the reports on our website, and all of the data from the lake keepers and the Carvel Lake project will also be uploaded to Mackenzie or to DataStream, where the data will be publicly available, and you can download it and look at the data yourself. So if you're curious about our data for Lake Keepers program, you can find it on DataStream. And I know I'm focusing mainly on our summer program, but I can't have a program overview presentation without mentioning our amazing Winter Lake Keepers program. I think it's one of our most exciting programs that we have. So just quickly, I'll say, I'm going to begin to work on the report from last winter's data once this field season is wrapped up. Last winter, we had a lot of sampling occurring. We had 88 sampling events from 48 locations across 41 lakes. So it's a lot of data to dig into, and I'm looking forward to compiling it and seeing what we've got. Yeah, and we had some additional samples that were taken last winter as well, some additional nutrients and other water chemistry data that we didn't collect in the previous winter. So really looking forward to seeing what we observed last year. And if you are interested in participating in the Winter Lake Keepers program this coming winter, feel free to email me, and we're going to probably be delivering another training webinar for the program sometime in late November, early December. So keep an eye out for that. And if you have any questions about this program, then definitely don't hesitate to reach out to me at my email. All right, moving forward onto what we've done for recreational water monitoring this summer. So this is a new project that we've been a part of this year. It's really exciting. So we've been formally added into the provincial recreational water monitoring program that's run out of, it's delivered by Alberta Health and Alberta Health Services. So the reason why we were included in the program is to help build capacity to sample, primarily using our staff and also our volunteer network, and also support through other means as well. So yeah, so our primary contribution was sampling at priority beach locations to gather samples for cyanobacteria and enterococcus. So in order to deliver the program, we needed to hire somebody, because this is not something that we could do to the best of our ability, just with all the other programs that we're doing, that Brad and I are coordinating. So we hired our recreational water technician, Tina, this year, and she's been amazing. She, at the beginning of the summer, she first learned about our whole volunteer network, and was asking us questions all the time: who's where, how can they help? And she did a great job of kind of like learning about all of our capabilities in a very short period of time, learning all of our volunteers. And she was really important with developing some training materials as well. So at the beginning of the summer, she worked with AHS to deliver a training webinar for samplers. And then this fall, she's going to be developing some videos as well that we can use to share with future samplers to help them know how to take these samples. Most of her time was spent sampling, and lots of these locations that you can see on the map, she actually sampled weekly. So it was a lot of time that she spent driving around and also coordinating other folks, partners that we work with and volunteers to sample their locations weekly as well. And our staff as well that are sampling through the Lake Watch program. She also made sure that they had everything they needed and knew what to do in order to do the sampling. So she spent a lot of time doing that, and she did a great job. And she's also doing some site assessments this fall as well, where she's going to specific beaches in the province and kind of learning about some of the risks associated with these beaches, and just kind of understanding what are some of the priorities for making these beaches a bit safer for the people that like to enjoy them. And I just want to do a quick shout out to some of our partners and volunteers that supported the recreational water monitoring this summer. The North Saskatchewan Watershed Alliance, stewards out at Calling Lake, the Mighty Peace Watershed Alliance, and then a volunteer through Lac St. Anne Lake Isle, their stewardship association. And now I'm just going to go over some stats as to what all we did. So for Enterocockus priority beaches, there were 8 beach sites from 8 lakes that we were able to support 46 sampling events at. So this included doing a visual inspection at these locations, gathering samples for fecal coliform amounts, and also some of these locations had source tracking that were done to understand possible sources of the fecal contamination. As far as cyanobacteria, there were 19 beach sites that were sampled from 18 lakes for a total of 80 sampling events. So same thing, there were visual inspections at these sites, and the samples that were gathered at these beaches went on for cyanobacterial cell counts at the U of A, which included the number of cells as well as species identification. And then another sample was taken for toxin or specifically microcystin levels. All right, and then another thing that kind of worked alongside that program was to support research that's being done at the Hannington lab at the U of A. So it was really easy for Tina, our staff, and our volunteers to be collecting samples for this research program alongside the recreational water monitoring. So they took samples that will be used to validate field and community-based qPCR techniques for Enterococcus monitoring. So it's a really cool project. It kind of works towards using citizen science to gather more data, specifically at beaches. So we're really happy to be part of this this research again this year and to support Patrick Hannington. And the site locations you can see on the map there were primarily from beach samples, beach sites that were priority sites through the Alberta Health Monitoring Program, and then other opportunistic locations. So lakes that our technicians were sampling at for Lake Watch, or other ones they were just driving by. And we actually had an intern from Patrick Hannington's lab come, and she was running qPCR analysis at her lab, and it was Sarah. She was really great to work with as well. We also had similar partners collecting samples for the eDNA project. So thank you for all your hard work. There were 154 samples taken from 44 lakes for this research. Really cool. We're really interested to see where this research will go. Right, just checking the time here. Okay, I'm doing okay. So another project that we spent a lot of time working on this summer is the satellite validation for algal bloom monitoring in Alberta. So this is the second year we've been doing field work for this program. So just to give a quick background on the project, it kind of came out of some discussions that the Technical Advisory Committee for the PLWA was having to help them learn more about some of the blooms that Pigeon Lake is seeing. So one of the things they wanted to pursue was to develop a satellite-derived chlorophyll A monitoring tool. And what that required was taking samples on the lake at the same time that the satellite was going over, to make sure that the values that the satellite is measuring for chlorophyll A is actually representative of what the surface chlorophyll values are. So we did that last summer with the support of the PLWA in collaboration with Rolf Feinberg from the U of A, Alberta Environment Parks, and the ABMI. And we were able to develop a model for Pigeon Lake last winter, and we have a working online visualization tool for Pigeon Lake that's up and running. It needs a bit more development, but we're still working all together and in collaboration with the PLWA to make this model very friendly to the public and interactive. And it's still in development, but one of the takeaways from the work last year is that to continue to validate this model at Pigeon Lake, we want to be able to apply it to other lakes in the province, and we need to know, are lakes comparable, or do lakes need to have their separate models developed depending on differences between them? So that led us to doing more of this validation work at other lakes in the province. So we decided to do this validation work at Wabamun Lake, Lac La Biche, and Lesser Slave Lake. And the reason for selecting these 3 lakes is that they each have a history of varying levels of cyanobacterial blooms, and they also had very interested parties, so either stewardship groups or municipalities that were doing work on these lakes already in the summer, or they're just really interested in this work and wanted to support it. So Wabamun Lake, we worked with the WWMC, the Wabamun Watershed Management Council, to sample the lake 3 times in the summer, and we got to 35 sites. And we timed it with 2 satellites that we used for the project, Sentinel-2, which goes over Alberta every 3 days and has really high spatial resolution. And then with Sentinel-2, which goes over Alberta every day, but has a bit lower spatial resolution. So that's what it looked like at Wabamun. As far as Lac La Biche, we coordinated sampling with the Lac La Biche County. So they, for Wabamun, we actually had our own staff going out with the volunteers to sample, but for Lac La Biche County, we set them up with all the equipment. They sampled on their own, and then we had to get the samples back to Edmonton. So the idea was to sample 20 sites on each of the 2 basins, east and west, 3 times over the summer, and again, try to time it with the Sentinel-2 flyover, which occurs every three days in the province. As far as Lesser Slave Lake, the province was already going to be doing standard sampling at Lesser Slave Lake this summer, so we thought it would be really great to just send the materials up with them and for them to do this sampling while they were doing their standard sampling. And because of that, we only were validating Sentinel-3 just for logistical constraints. And that involved taking samples at 15 sites from each of the basin. The goal was to do 3 times over the summer. And also the Lesser Slave Watershed Council has been supporting this sampling as well. When in instances where the province has sampled and it's been cloudy, then we contacted the Lesser Slave Watershed Council, and they've been really great in also supporting the sampling as well. All right, so what does the sampling actually look like? So as I said before, it's a variety. We would go to a variety of locations across the lake and get surface samples that we use to get pigment concentration, so primarily chlorophyll, but then also accessory pigments that are indicative of different types of algae and or cyanobacteria. We also get a surface grab sample for phytoplankton or algae count and species identification. And then other supplementary data is collected as well, such as Secchi depth, water depth, wave height, and GPS, the most important, so we can actually align the pixel with the water sample. And new for 2021, we've also included collecting a composite sample for total suspended solids, which I'm going to get to in the next slide. The most logistically challenging part of this program is timing the satellite flyover for Sentinel-2 with optimal conditions. And I'm going to kind of talk about more of that in a later slide. But why are we kind of focusing, or why are we including suspended sediments, is it kind of came out from a conversation we had with Environment Canada and their EO Lake Watch program where they're using Sentinel-3 to develop models as well for chlorophyll, surface chlorophyll levels. And they have models made for Lake Winnipeg, Lake of the Woods, and Lake Erie. And one of their focuses was to determine some of the sediment interferences, surface suspended sediment interferences with chlorophyll levels, particularly in Lake Winnipeg. And while we don't necessarily see similar, say, sediment plumes in Alberta lakes, we do see them in Lesser Slave Lake, like you can see in this imagery. So it is important for us to consider the interferences in knowing if they're altering the true values of chlorophyll at the surface of the lake. So just to kind of give an update as to how the summer actually went. Like I said, our goal was to try to get to each basin 3 times. Wabman, we've succeeded with that. You can see the 3 images here indicate the 3 days that we did sampling. So the first day, we're a little bit unlucky that the clouds for Sentinel-2 interfered with much of the lake, but for our August and September samplings, we had absolutely perfect days. And then for Lac La Biche, we've done each of the basins twice each. We're trying to get to 1 more of the Lac La Biche basins by the end of the month, but September has been very challenging. If it's windy, it's clear, or if it's clear, it's windy. And if it's going to be calm and it's really cloudy. So we've just been having a challenge getting the last sampling done at Lac La Biche and Lesser Slave. Similar thing, we're trying to get to 1 more basin by the end of the month. But earlier in the summer, we got 2 sampling events done on the East Basin and 4 on the West. So thanks again to Lac La Biche County, Alberta Environment and Parks, WWMC, and the Lesser Slave Watershed Council for all their hard work doing the sampling. It's not easy. We email a lot to determine if it's going to be the right day to sample. So I thank you all for your help with that. And yeah, I said I was going to talk about some of our challenges. So that first image on the top showing Lac La Biche, it seems like that would be a great day to go out. But on that day, the winds were above 30 and there were white caps. So we were often dealing with this where it's looking like it's going to be really clear, but it's not safe to go on the water. Other times, we're looking at cloud forecasts before we do this sampling. And, we try our best, but clouds are really difficult to forecast. And many of a few of our samplings, we've gone out and the imagery comes back with some cloud coverage, and that just kind of comes with this work. And the last is actually smoke here. You can see at Lesser Slave Lake, Alberta Environment sampled the lake on July 7th, and they decided to take these validation samples alongside their standard sampling. And you can see that the imagery looks a little bit hazy there, and that's due to some smoke. So we're going to have to work with the geospatial specialist with ABMI to determine, are there significant interferences of smoke with these surface chlorophyll values? And yeah, and we may be able to not use some of our sampling depending on the level of smoke during that day. So a couple of challenges this summer, and as well the having to time the sampling with the satellite flyover, along with the sample processing requirement of having to filter these samples within 24 hours made for a lot of fun, this project being a lot of fun. And but it's all worthwhile because we get to develop really valuable tools such as this one that we developed for Pigeon Lake. So this is kind of what the online tool looks like. You can choose the date range. You can choose whether you want to look at chlorophyll, or you can also change it so you're just looking at the imagery, the raw imagery, and you can select between the Sentinel-2 high spatial resolution satellite imagery or Sentinel-3, which has lower spatial resolution but higher temporal resolution. And yeah, this is what we want to try to develop for those other lakes. And if you want to learn more about this tool in particular, the Pigeon Lake one, Evan Delancey with the Alberta Biodiversity Monitoring Institute, ABMI, is going to be presenting in our webinar series next week. So he's going to go a lot more into the nitty-gritty for how we actually do develop this tool and the models to translate satellite imagery into surface chlorophyll. So definitely check that out if you're interested in this work. So now to wrap up this project really quickly, some of our next steps are to use these 2021 samples to validate the pigeon model and to see, you know, are these lakes different in the models that they develop, or are they fairly similar? We also want to use some of these additional pigments that I talked about we're getting data for that are more indicative of cyanobacteria or other types of algae, because chlorophyll is just all photosynthesizing microorganisms will have chlorophyll. So it's not specific enough to cyanobacteria bloom. So we want to see if some of these other pigments that are more specific to cyanobacteria we can use them to develop these tools. And also if we can use, you know, a pigment for diatoms to sort of visualize what a spring diatom bloom looks like, which is a common occurrence in Alberta lakes as well. And then we want to continue to develop the online tool and to include our other validated lakes, Lesser Slave Lake, Lac La Biche, and Wabamun. And if our validation and our project kind of determines that, you know, these lakes are fairly comparable, we may be able to add other lakes that aren't necessarily validated. If the model is stable enough between lakes, we may be able to add other lakes that haven't had this validation, which would be really, really great. So look forward to where this project goes. All right, so I just have a few more quick slides and then I'll wrap up. We spent some time out at Little Beaver Lake this spring doing some tributary sampling because we're working with the stewardship group at Little Beaver to develop a nutrient budget for the lake. So we went out to Little Beaver and did tributary sampling at all of the tributaries and the outflow during the spring freshet. We also did a standard lake watch sampling, which also included some sediment samples. And we were planning to do tributary sampling after storm events throughout the summer, but we never had enough precipitation at Little Beaver to actually get any flow from our tributaries. So that didn't actually occur. It was such a dry summer. And then following the summer, once we have all of our data from our field work, we're going to be compiling a water balance and a phosphorus budget and then a report to help us contextualize some of the nutrient dynamics of Little Beaver. And that work is supported by Alberta EcoTrust. So keep an eye out for that. As far as our monitoring for Eurasian water milfoil, we have collected 40 specimens from 38 lakes this summer, and none have come back as Eurasian water milfoil. So the specimens are sent to the Alberta Plant Health Lab, where they use PCR techniques to genetically differentiate whether the specimen is our native northern water milfoil or the invasive Eurasian water milfoil. And they've all come back as being genetically the northern water milfoil. So that's really great. We want to continue to only see northern water milfoil in the province and not Eurasian. And thanks to the North Saskatchewan Watershed Alliance and Lac La Biche County for also contributing some samples to this monitoring program. And we have selected a recipient for our scholarship, Ferdis Nawar, out of the Aquatic Ecology Lab at the University of Calgary. We first started actually working with her through our winter work. She was somebody who wanted to do some winter sampling because her project is all about winter lake conditions, which was really interesting to us. So you can see the title of her project there, but some of her main questions are: how does ice cover quality impact algal community structure and productivity? And what are some of the long-term thermal, chemical, and algal dynamics changing into seasonally ice covered lakes in Alberta, where we have a lot of this seasonal data, and the lakes are Nakamin and Ethel. And then kind of factoring in how climate change might be impacting both of these ice cover and long-term trends at these lakes. So really interesting work. And she will hopefully be presenting at our ALMS 2021 AGM. I think she is she will be in mat leave around that time, so she may, depending on when the delivery is, the baby, she may not be able to present, but we will get her to present later on. So yeah, we will get her to present to our network eventually, because we want to learn more about her great work. And now just to kind of sum up what we're going to be up to over the next little while, we have our AGM, like I mentioned, coming up in November. We haven't selected a date, but stay tuned. from when that is. It'll likely be online. I'll be working on the Winter Lake Keepers report from last winter this coming fall. And we will be doing our Winter Lake Keepers program again this winter. So like I said before, if you're interested and you want to volunteer for this program, reach out to me. We'll be spending a lot of time doing Lake Watch, Lake Keepers, and the Carvel Survey report writing and data analysis over the winter. And then we have various program planning and development that we're going to be doing throughout the winter as well for various programs, including the satellite work, Lake Keepers, and some other exciting programs we have in the works. And I can't finish off a presentation like this without recognizing all of the great help we've had from our partner organizations and volunteers. We definitely couldn't have done everything we did this summer, and we do in the winter as well, without your support. So thank you all so much for your help. We really like working with all of you. So yeah, thank you so much. And with that, I will happily take some questions.
Okay, great. Thanks so much, Caleb. We'll just get this quick one out of the way. Richard says, count me in for taking winter tests. So we definitely
Sounds
will,
good. Thanks, Richard.
Yeah. The first question that came in is from Tristan, and he said, we have found the single best predictor for our state's lake bloom signals has been summer precipitation events. With high temperatures but drought this summer, it has been fairly clear lake year for Secchi transparencies. Have you looked at your lake's data in a similar capacity?
That's a really great point. It's something that we have thought about in sort of contextualizing what we're seeing year to year. And it's interesting, 2019, 2020 in Alberta have been, were fairly wet years. And depending on the lake identity, we did see some particularly high levels of cyanobacteria and sometimes lower as well, but we haven't specifically looked at precipitation. We haven't added that into our data analysis. So it's interesting that you've said that works for your state, and it may become a part of our data analysis in the future. But yeah, we haven't done that yet, but I think it'd be really interesting.
Yeah, and we had a very, very dry spring. So I don't think we had much runoff in the spring, which I think brings in a lot of nutrients. So it's a very odd year for us. Oh, and Tristan clarifies that he's in Maine.
Maine, yeah.
Okay. Lauren has a question here. Maybe I can help answer this one. For instances mentioned for waterfront landowners and the need to promote private water stewardship, is there currently any resources specifically for waterfront owners explaining how their activity, both aquatic and terrestrial, can affect the lake ecosystem? In BC, I know it is a major issue where waterfront landowners alter their shorelines to prevent erosion, for example, but are unaware of the implications of their actions. It's a great question. It's, one of the most important pieces of, I think, doing this work is making sure that people are being good stewards of the land. And there are a couple of resources in Alberta. I would point you to Nature Alberta has a document called Living on the Waterfront. And this is a great guide for people with shoreline properties. And as well, the Pigeon Lake Watershed Association has their Clean Runoff Action Guide. That's another great resource that's out there. So the resources exist. The challenge, I think, is in making sure that they're being read and that they're being implemented. So I think that's probably a universal challenge, but if you want me to send you any links to these documents, I'd be happy to do that. Tristan is asking, what tools are you using for data tracking or project management? It seems like you're doing great work in a number of different areas. Kudos. Yeah,
so we use quite a few different approaches for managing data. As you can imagine, we're getting a lot of data from different sources all the time. Thankfully for our Lake Watch program, because the data ends up going into the provincial data set, we have really great support from the province and their data management team to make sure that all the data is going to the right place. And then we work with them in the fall to do the data validation and QA/QC. So that's how we manage the Lake Watch data. And there are a lot of different ways as to how the data actually ends up in that database, depending on the type of data, whether it's coming from the lab or if it's from some of our profile data. But for the vast majority of our programs, we, at least for lake keepers and the Carvel project, we are working with DataStream, which is this publicly available database for water quality information in Canada. And they have a really great system set in place for any group, whether you're a nonprofit, you're in industry, you're a government. Their database is designed for all water quality data, and they have a really great uploader template that I use all the time to transfer our data from lake keepers and this Carvel project that will eventually go into that database. And then as far as project management, if you're wondering like how we communicate with everybody, within ALMS, we like to use Slack, and that works really well. And then I'm just emailing all the time, which is great because I get to work with really great people. And then, yeah, lots of our data analysis that we do in-house for our reporting, we do in R, and it makes life really easy. Hope that answers your question.
Yeah, lots of spreadsheets.
Yeah.
Keeping track of everything. Yeah, it feels like we're juggling like 6 different things in our heads most days. Jackson sends his condolences to the Lost Secchies. Thank you, Jackson. He's curious to know what the accuracy of the data is when comparing grab samples versus satellite imagery. Yeah,
that's a great question. I can say kind of off the hop, thinking back to some of our meetings where our ABMI counterpart presented this data for Pigeon Lake. For the vast majority of samples, actually, they were very tight. So we actually got a pretty good validated model out at Pigeon Lake. And that I'll just say again, if you're interested in how all this is kind of happening, we're mainly focused on the fieldwork aspect, but it's Evan Delancey at the ABMI, which is actually spending the time doing the math behind the scenes and doing this geospatial work. And if you if you are gonna tune in for next week's presentation from Evan, I'm sure he's gonna go a lot more into that to explain how tight some of the values are. But off the top of my head, remembering the presentation and some of the figures, it was surprisingly very good.
Yeah. Bruce is interested in reading some of our lake reports for cyanobacteria analysis. Is this available on your website?
Yeah, that's a good question. If you're thinking about what I mentioned about cyanobacteria from our Lake Watch program, so we do have Lake Watch reports that you can learn what the general cyanobacterial levels were through chlorophyll A, which we use as a proxy for our phytoplankton and cyanobacteria. We are taking phytoplankton samples through the Lake Watch program, which we send off eventually to get analyzed and get taxonomic and enumeration data, but we don't formally include that data within our Lake Watch reports. We also have microcystin data, which we present in our reports as well, which kind of give an overall level of just microcystin, a toxin produced by cyanobacteria, to know generally if these cyanobacteria are releasing microcystin toxins into the water through the summer. But I would say if you're interested in more species data, they're through the beach monitoring program that Alberta Health and Alberta Health Services delivers. There's all of their data that they've collected from beach sampling, which includes microcystin data and cell counts, including the counts of specific species of cyanobacteria. That's all publicly available through the Alberta government's data portal. So I would say that's probably your best bet to look at cyanobacteria data and that ALMS currently doesn't have, aside from chlorophyll and macrocystin and sort of like pictures and anecdotes possibly in our reports, we don't really get into the nitty-gritty of the species composition.
I just included a link to our Lake Watch Report page. If anyone's curious about a specific lake, check it out and let us know if you have additional questions. Michael is wondering why we're doing DNA analysis of milfoil specimens rather than simply using physical characteristics. He thought they were easy to differentiate.
Yeah, that's a great question. In our experience, we've actually observed northern water milfoil to be very plastic in some of its physical characteristics. And we're actually capturing some of this because alongside sending the specimens off to the Alberta Plant Health Lab for DNA genetic analysis, we're also pressing these specimens, and they're actually fairly plastic in some of their characteristics. But some of the classic characteristics that you use for differentiating them, number of leaflets, and even how the leaflet, if it's squared or rounded off, that can be sort of plastic, I would say, as well. It's not always reliable, I would say, from our experience, and that we want to get a bit more confidence. And through our partner, the aquatic species specialist with the Alberta government, she actually set up this program, or this an analysis step where we can send it to the Alberta Plant Health Lab to get really confident DNA results for the specimens. And I guess another concern as well is that the two can hybridize, and we don't really know at this point whether the test and how it's set up will actually be able to capture a hybridized sample of being northern or Eurasian, depending on what primers it uses. But that's also a concern. And if they're starting to hybridize, then I don't think that some of these physical characteristics are going to be the best way to differentiate between the two species, and even if they're hybridized. So I'll let Brad elaborate on that if he thinks there's anything else with that.
No, I'll just say that the lab is also able to detect other milfoil species beyond Eurasian and northern, and for example, world milfoil. And in some cases, you need to see the bracts under each of the flowers, and we don't always have a whole specimen when we're collecting samples. So the DNA analysis just gives us that extra detail. And yeah, the hybridization is a big concern for sure. So it's a great addition to the program, and kind of validates our own identification, which is sometimes tricky when you just have a fragment. So yeah, it's a great question. Those are all the questions, and we're right at 12. So before we wrap up, as we mentioned, for those folks who submitted a question, we do have a draw for one of our Lake Watch t-shirts with our nice 25th anniversary logo on the back. So let's just refresh this spreadsheet here. Okay, our winner this time around is Richard from Half Moon Lake. So we'll make sure we've got your contact info, Richard. We'll make sure that we get that over to you. And I'll just bring up here, we do have one more webinar in this fall webinar series, and that's next Friday at the same time, 10 to 12. Our speakers are Gertrude Nurnberg from Freshwater Research in Ontario. She's talking about her work on internal phosphorus loading. And then, as Caleb mentioned, we'll be hearing from Evan Delancey at the Alberta Biodiversity Monitoring Institute, who will be speaking about satellite algal bloom monitoring at Pigeon Lake. So if you want to see that model kind of in action and see the details of that, that will be a great time to do so. Again, thank you so much to our speakers today, Caleb and Candace. Really appreciate all the effort that goes into putting these presentations together. And the presentation is recorded, so If you have missed some of the previous week's presentations, I encourage you to check them out on our webinar page or on our YouTube page, and this one will be posted shortly as well. And yeah, with that, just again, thanks to all our participants, always great questions, great participation. And I think that's everything. So I'll go ahead and close out the webinar now. Thanks, everyone.